All right, today we're going to talk about section 7-5, determine outcomes of compound events. So today we're going to talk about compound events. That would be more than one event. So example 1, find all possible outcomes using a tree diagram. So our question is, Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are in a family with 3 children that all the children will be either boys or all girls. So how can they determine all possible combinations of boys and girls in a family with 3 children? So once again, how can they determine all possible combinations of boys and girls in a family with 3 children? Okay, so basically what they want to know is, if a family has 3 kids, what are all the possible combinations of those 3 kids? Obviously, boy or girl. So step 1, we're going to list all of the different events. So there's 3 here. Child 1, child 2, and child 3. Okay, so for each event, there are 2 possibilities. Okay, boy or girl, boy or girl, boy or girl. So all these 3 events, when they're together, they are called a compound event. It's more than one. So a compound event consists of 2 or more events. So this compound event, right, our 3 kids, consists of child 1, child 2, and child 3. Each one of these we would call a separate event. Okay, and all we've done is we've listed 1, 2, 3 events. Child 1, child 2, and child 3. Okay, step 2. We're going to make a tree diagram to represent the sample space. Remember, a sample space is basically where we just list all of the possibilities, all of the combinations. Okay, so remember, a tree diagram, if you don't remember, shows all possible outcomes of a compound event, right? They also show all of the possible combinations of a compound event. So remember, our 3 events are child 1, child 2, and child 3. Now notice our first event here, child 1. You either have a boy or a girl. So each one of these branches just represents combinations. So let's say child 1 was a boy. Well, then you could say, well, what if they had another boy, and then what if they had another boy? Each one of these things are different branches, right? And they each follow their own path. And each stage of these branches, okay, represents each event, right? This is event 1. This is event 2. And we would say this is event 3, okay? First child, second child, third child. And we notice down at the bottom, they have the combination. So let's go see what this red box entails here. Okay, Haley and Josh can make a tree diagram, as we see to the right, to show the sample space of all boys and girls in a family with 3 children, right? All the possible combinations. The letter combinations below each branch, and when I reference branches, as I said before, branches like this, boom, there's a branch, and it brings me to this. B, B, G, boy, boy, girl. That's one possible combination. So the letter combinations below the tree's diagram, the tree diagram's branches, represents all of the possible combinations of 3 male or female children. We can also see that there are 9 total combinations, 1, 2, 3, 4, 5, 6, 7, 8, 9, of 3 male or 3 female children for this compound event. So each one of these combinations of letters represents a outcome of this compound event, right? You could have one outcome is all boys, one outcome is all girls, one outcome is 1 girl, 2 boys, one outcome is 2 boys, 1 girl. So all of those are different outcomes. Okay, so there we go, a compound event. So let's go ahead and move on to example 2. So example 2 says, use a table. So notice the first example, we use a tree diagram. Now we're going to use a table to represent sample spaces. Okay, so it says a game is played by spinning 2 spinners. Players match the results of the spinners to combinations of their game cards. How many different combinations are possible? So they're spinning a spinner with letters, we're spinning a spinner with numbers, and we're looking at all the different combinations. So we're going to use a table to represent this sample space. Okay, this is a table. We're going to fill it out. Remember, the sample space shows all possible outcomes. So let's look at our table and how we have it set up. So this horizontal row represents our blue spinner. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, so on. Our vertical column represents our letter spinner, A through F. And all we're doing in each box is putting the combinations. So like, let's say we spun a C and we spun a 3, C3. Or if we spun an F and spun a 5, F5. So all of our different combinations. So the table is 6 by 6. There are 6 letters, 6 numbers. So the question is, how many different combinations are possible? It should be pretty apparent to us what that number is. So we can say, and this is a long one here, make sure I explain it well enough. Okay. There are 36 different letter number combinations. We know this because there are 36 total boxes, so you just count them up, 1 through 36. We can see that really easily on our table. We can also tell that there are 6 different spaces on the red spinner and 6 different spaces on the blue spinner. So when we have these two combinations, what we can do is simply multiply them together to get our answer, right? 6 spaces on one spinner, 6 spaces on the other spinner, so we get a total of 36. Therefore, the sample space consists of 36 possible outcomes or combinations for this compound event. So one way of finding total number of outcomes is by simply multiplying the outcomes for each individual event. So in this case, there are 36 total outcomes. Okay. Let's look at example 3. Now we're going to use an organized list, okay, to represent sample spaces. It says Stan will roll a number cube or a dice labeled 1, 2, 6, 1, 2, 3, 4, 5, 6, and then flip a coin. What are the possible outcomes? So we're going to roll a dice, flip a coin. We're going to use an organized list. Okay. Now an organized list is a way of listing all of the possible combinations and outcomes of a compound event. Basically, you're just listing out. There's no table, there's no tree. We're just listing everything out in like a sentence almost. Okay, so it's a way of listing all possible combinations of a compound event. All possible combinations. So in this case, now these can be a little bit confusing to read, so let's go through this pretty easy. So if I roll a 1, I can combine that with either a heads or a tails. If I roll a 2, I can combine that with a heads or a tails. If I roll a 3, I can combine that with heads or tails, and so on. We can do that for 4, 5, and 6 also. So basically, we're just matching up all the letters with either heads or tails. Now, what are all the possible outcomes? Well, they should right there be in our organized list. There are 12 different ones. 1, 2, 3, 4, 5, 6. There are 12 different combinations. Therefore, there are 12 possible outcomes. Now, another way we can do this, well, how many outcomes are there on a dice? Well, there's 6. How many outcomes are there when we flip a coin? 2. Well, we can multiply those two things together. What do we get? We get 12. Once again, we can multiply the outcomes of each individual event to figure out how many outcomes or combinations there are with our compound event. Okay, so let's review this. A compound event is a combination of 2 or more. Could be one event, it could be 2 events, could be 15 events, it doesn't matter. An organized list, a table, or a tree diagram can be used to represent a sample space of a compound event. Okay, now let's just go over this. Okay, so the sample space for flipping 2 coins consists of 4 outcomes, as you can see below. So here's an example of flipping 2 coins. If we describe that in an organized list, 2 heads, heads, tails, tails, heads, 2 tails. Boom. We've just listed out a table. We have a row, we have a column, and we're just matching them all up. And here's our tree diagram. Here's event 1, and here's our second row. Heads, 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 tails, tails, heads, tails, tails. Okay. And those are all of our different outcomes. Organized list, table, tree diagram.